Now this involves a block of wood which has 3 dowels. These are drilled into it and held there with glue, but you don't have to use dowels. You can just take 3 big screws and put them in there too. That's all right. It works either way. It works fine. But what this is my Newton car, and it's got these 3 sticks there. And then I've got some rubber bands, and if I take these rubber bands and pull them back, I have made kind of a slingshot. Well, what I got to do is to get rid of that one. Put them on here so that the slingshot stays cocked. And the way to do that's quite simple. Here are 2 rubber bands I'm using right now, and I have a loop of string that's I already pre-tied. So there's my little string loop. Can you see that on there? Okay. I just simply slip that on there. Then I take the 2 rubber bands and put them over the post, and I pull on the string loop like this. And you can see how when I pull on that, it stretches the rubber bands. I'm just going to pull it all the way back and slip it over the rear post. There we go. I now have a slingshot that is already set up, ready to fire. Okay. That's our first step right here. Then I need something to shoot. So I'm going to use a medicine bottle. This size is actually called by the pharmacist 8 drams. It's your little pill bottle, like a 30-day supply pill bottle. And this one happens to be filled with just ordinary beach sand. You can put water in there. You can put metal washers. You can leave it just air, whatever you want to, but you can change the mass. Now this, in the case of a rocket, represents the gases shooting out the back of the rocket. This represents the rocket, and the rubber bands have to do with how fast things get to shoot out the back of the rocket. So I'm going to place it right in there and get these rubber bands balanced just about right. So it's just about where the center of mass is with this. There we go. So there we are. Now I have a car with the bottle that's got sand in it to make it fairly heavy, the rubber bands, and I got the string right here holding it. Then I'm going to place it right over here on the straws. The straws become my rollers. So it's like instead of having wheels, I got all these straight straws. The next trick is you got to cut the string. Okay? You can do it 2 ways. One way is to take a scissors and it takes a little coordination and just kind of get in there and go snip and move your hands out of the way. That's pretty fast. But I guarantee kids will love it this way instead. All right. I don't mean using a propane torch, but I forgot my matches. So I take a match or a little butane lighter. This is kind of overkill, but oh boy. But you guys in here will understand, won't you? We know how to do this. Okay, here we go again. I'm going to turn this on. There's a little bit, everybody's running away. Okay. There's a little bit of string hanging down from the knot. Come on. I'm going to try to light that little bit of string. Oh. Believe me, the kids will much prefer to use matches. Okay, good. Now here's the deal. You can vary the experiment. If you have it filled with sand, you can go out and measure that, what the mass of this is. You can take an empty pill bottle, and how will that affect how far it goes? You can change the number of rubber bands. 1 rubber band, 2, 3 rubber bands, and in doing so, you change the acceleration from low acceleration to higher. So you got several variables here you can work with. We only change 1 at a time. So let's say we start with this one with one rubber band, then 2 rubber bands, 3 rubber bands. Each time we measure how far it goes, and we graph it. Good math right there. By the way, scientific controls are very important. If one time you have all the straws beautifully lined up like railroad ties, next time it looks like something weird like this, it's not going to roll the same way. You got to do it exactly the same way each time. So actually, I might put down little tape markers right there to show where each straw would be. Or the kids, they have to mark it in some way to know and make it exactly the same each time. The string loop has to be the same size. So they have to tie several and make sure they're all the same size. If one is shorter than the other, it'll pull the rubber bands back farther. And that'll give you more, that'll throw you off. So there's a lot of variables to control for, which is a good thing. Because, you know, you're working with kids. You've got to control variables in their experiments. They've got to understand that's an important part of the research process is controlling the variables. Well, that's my Newton car activity. I really like doing this one because it tells us about Newton's second law of motion in particular. Now, it does all 3. It sits there we have an unbalanced force that takes off. Action, reaction, goes that way, goes this way. But the second law is if you got more mass, greater distance it goes. More acceleration, greater distance it goes. If you increase the mass and the acceleration, even greater still. You can plot out and see the relationship on your graph from one empty, 2 rubber bands, empty, 3 rubber bands, empty, 1 rubber band, full, 2, and you try all these different trials, and you see the relationship between force and mass times acceleration. So that's why I like this activity very, very much.